Welcome to question 10 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 10 we're told that the line y equals ax minus 1 is a tangent to the curve y equals x to the power of a half plus d at the point 9c, where a, c and d are real constants. And we're asked to find the values of a, c and d for this question. So it's not required, but we're going to actually start this question by sketching the functions that we're dealing with. So here is going to be the y-axis, and this is going to be the x-axis. And first of all, we're going to sketch y equals ax take 1 in green. So this is a straight line with a gradient of a and a y-intercept of -1. So that's going to look something like this. So that is y equals ax take 1. Then in blue, we're actually going to sketch the graph of y equals the square root of x plus d, because we know x to the power of a half is simply the square root of x. And d just translates the graph up or down. Now to be a tangent at the point 9c, this is probably going to be translated down here somewhere. So that would be technically 0, d. And then it's going to be a square root graph. It's going to be a tangent at this point. And that point is at 9c. So this point here has coordinates 9, c. So now that we've got that set up, we're going to unpack this question a little bit further. So first of all, to be a tangent at 9c, the gradient of this tangent line must be equal to the derivative at that point. So we're going to start by calculating dy dx, which is the derivative. So dy dx is equal to, and for this function we have power out the front is a half x, and then when we take 1 off the power this becomes negative a half. D is a constant, so it turns into 0 when we differentiate. So cleaning this up slightly, we can say dy dx is equal to 1 divided by 2, and now the negative puts it on the bottom line, and the half is equivalent to a square root. So that's an expression for the derivative of x to the power of a half plus d. Now we want to consider when x is equal to 9, which is the value when that is a tangent to the curve. So that will give us dy dx is equal to 1 divided by 2 times the square root of 9, which is 1 divided by 2 times 3, which is 1 on 6. So that means that a must equal 1 on 6. And a reminder that that's because to be a tangent to the point at 9, the gradient of that straight line must be equal to the derivative at that point. So using that information, we know that y equals x on 6 take 1 is the equation of the tangent line. Now we're going to use x equals 9 again. So when x equals 9, our y value is going to equal 9 over 6 take 1, which actually equals a half when you do the simplification down. So that will tell us that our c value must equal a half. And we know that because they must share the same y value if y equals ax take 1 is a tangent to the square root of x plus d. The last thing we need to do is find the value of d. And we're going to do that by substituting in the point 9, a half into the rule. So when we do that, we get the y value of a half is equal to the square root of the x value of 9 plus d. So therefore we find that a half is equal to 3 plus d, which means that the d value in this question must equal -5 on 2. So that is the final value that we needed to find for this question. So from the examiner's report we can see that just over a third of students got full marks for this question, with quite a number of students only getting 0 or 1 marks, so meaning that they didn't really know where to start, or if they could get started they weren't sure where to go. So from the examiner's comments we can see most students understood that they needed to find the gradient of the curve and at the tangent at the same point. However, some thought they were dealing with a normal rather than a tangent, and many others thought that the gradient of the tangent was ax take 1 rather than just the coefficient of x. A number of students equated the y value to the gradient at x equals 9, which was incorrect. And another common error was to substitute x equals 1 rather than x equals 9 into some of those expressions along the way.